In this video, we're going to be rewriting quadratic functions from standard form into vertex form. So on the screen here, I see an example of standard form, and we're going to rewrite this standard form into vertex form. Now remember, vertex form is of the form y equals a times in parentheses x plus our h value squared, then plus k. So I have to start thinking about what have I seen in the past that has allowed me to write something into x plus h in parentheses squared. And when I think about all of my quadratic solving strategies, the only time I was able to create something where it's x plus or minus a number in parentheses squared was when I used the completing the square strategy. And if I think back to when I used the completing the square strategy, I was trying to figure out what I needed to add in to create something like x plus h in parentheses squared. That was kind of my final goal in completing the square, and then I was able to solve a quadratic, which we're not going to solve a quadratic here, but we're hoping to be able to create this particular situation. So if we want to rewrite something from standard form into vertex form, we need to use that completing the square strategy to help us out. Now, when we use the completing the square strategy to solve for x, we always got the items that contained x alone on one side of the equation. So we're going to do that here just to make things a little bit easier for us. So I'm going to subtract the 10 over and subtract the 10 over. So here I have y minus 10 is equal to x squared minus 16x. Now remember, my goal with the side of the equation that contains x, which is right here, is to figure out what I need to do in order to turn this into a perfect square trinomial. So my goal is I'm going to add something in here, some value, very, very purposefully, so that ultimately I end up with x plus or minus some number in parentheses squared. That's ultimately my goal. Now, the first thing I have to figure out is what number is going to go inside of that parentheses with x. And this is where our negative 16 comes in handy. So we take our negative 16 and we divide it by 2 to find negative 8. If we're going to create a perfect square trinomial, it needs to be with negative 8, because that's ultimately going to produce x minus 8 times x minus 8. So here we can just see, if we kind of quickly brainstorm, x times x would give us this x squared here, then x times negative 8 would give us negative 8x, and negative 8 times x would give us another negative 8x, the total for that negative 16x. So we've already accounted for most of the multiplications here. What we're missing, and the piece that we need to add in, is negative 8 times negative 8, which is a positive 64. So if we take negative 8 squared, or negative 8 times itself, we find that a positive 64 is our missing piece here. So if we add a positive 64 into this problem, if we add that in, this piece can then be rewritten as x minus 8 times x minus 8, which then becomes x minus 8 quantity squared, which gives us something in parentheses squared with x. However, if we're going to add 64 to the right-hand side of the equation, remember, we have to add in 64 also to the left. We can't forget there's another part of this equation. So negative 10 plus 64, we get y plus 54 over here. And then realistically, standard form and vertex form both have y by itself, so we need to really subtract that 54 back over into our vertex form. So we subtract 54, subtract 54. So our final equation here with vertex form will be y equals x minus 8 in parentheses squared minus 54. So you can see here we were able to use completing the square to rewrite this from standard form into vertex form. And because our knowledge of completing the square is a little bit limited, we're only going to be doing the more simple completing the square problems. So you won't really have to worry about the a values here in Algebra 1, but we're just going to do those simple ones using completing the square to write simple standard form into simple vertex form. All right, so let's do one more example here. So again, remember to rewrite standard form into vertex form, we need to use completing the square to get that piece where we have x plus or minus a number in parentheses squared. So to start, again, I'm just going to temporarily move the 18 over so that I don't confuse it with the rest of the problems. We have y plus 18 is equal to, here we have x squared plus 6. So remember, my goal is I'm going to turn this into a perfect square trinomial. So we need to figure out what I need to add into this problem so that this will create a perfect square trinomial where it's something times itself, which ultimately gives me the parentheses squared piece. So if I take 6 and I divide it by 2, that is going to give me 3, and a positive 3 at that. So I know that inside my parentheses here is going to be x plus 3 and x plus 3, which will hopefully give me x plus 3 in parentheses squared. So if my goal is to make this x plus 3 times x plus 3, which is x plus 3 squared, I need to figure out what I need to add into this equation to make that happen. Well, if I take 3 squared, that gives me 9, and if I add 9 in here, I will create the perfect square trinomial that creates x plus 3 times x plus 3, which results in x plus 3 quantity squared. Now, if I add 9 into one side of the problem, I also have to add 9 into the other. So this is going to become y plus 27 here on the left. And then to end the problem, I need to get y by itself. So I subtract 27 from each side, and we end up with y equals x plus 3 quantity squared minus 27. So again, we use completing the square to go from standard form into vertex form.